Hello, and welcome to the first in a series of tutorial videos that I'm going to be making about Unreal Engine 4 and its new Niagara editor. If you're unfamiliar with Niagara, it's Unreal's new particle system that they're making to replace the current particle system, Cascade. It's still in beta, so there's not a lot of information out there about it, so I'm taking the time to learn it, and I figured if I'm taking the time to learn all these things through trial and error, I might as well share some of those learnings with other people. So that's what these videos are going to be. This first video is going to be pretty high level, just what is Niagara, what are the different parts of it, how it works, how it functions, how you change things, and how you go about making really basic particle systems. So if you're already kind of familiar with Niagara, this might not be the video for you. It's going to be a little long because I'm going to get in a really deep detail on each of the parts and how they work. However, if you've used Cascade before and you just want to see what Niagara is like, this is a good opportunity. Or if you just have never touched a particle system in your life, this should be a good video for you to start off with. I'll be making more videos after this one that will be increasing in complexity. So if this one isn't for you, but you're interested in the idea of learning how to do things in Niagara, stick around. I will be making more interesting videos in the future as well. So just to start off here, we're going to jump into the editor, and I have a project made up here. And the very first thing we're going to need to do, since Niagara is in beta still, is to enable the Niagara plugin. So we go up here to Edit, and we click Plugins, and then we scroll down to FX, and then we click Enabled right here. And it's going to ask you if you want to use this because it's unstable, and it could be removed without notice. I doubt they're going to completely remove the plugin anytime in the future, but it is a little unstable. It does crash sometimes, but it's not terrible. Just make sure that you're saving things regularly, but this is not too big of a deal, so just click yes. There's also Niagara Extras, which is just cool stuff that Epic did with it that they didn't think was core functionality, so it's not included in the core tool. We're not going to use that right now. I haven't really looked into it too much. So we're just going to stick with just basic Niagara, and we have to click Restart Now down here. So it's going to take a minute, and then we'll be back in a second to dive in. And we're back. So it pops back up with this window, but we should be able to access Niagara now. So what we're going to do is we're going to come down here to the content browser, click this to show the hierarchy. We're going to create a folder in here called Particle Systems. And we're going to create a folder in that called Water Drops, because the very basic particle system that we're going to be working on in this video is just a water drop effect, like water accumulating on a surface and then dropping down to the floor. Then we're going to open that and then right click on the content browser. And what you're going to be able to see here, which you would not have been able to see before we enabled the plugin, is there is FX down here in Advanced Assets. And if you go to that, you can see there are a whole bunch of Niagara options. So there are scripts and modules that you can make that really extend the functionality of Niagara and make it a super powerful tool. We are not going to get too heavy into that. We might take a look at what a module looks like, but we're not actually going to be writing any in this video because it's very basic. The two most important things for this video are the Niagara emitter and the Niagara system. And we're going to start off with the emitter because that is basically like the building block of a particle system. So the first thing when you click emitter, you see is it's asking you what you want to do. So you can create a new emitter from a template. You can copy an emitter that you've already made and then make changes to that, or you can create a completely empty one. What we're going to do is we're going to start off with one of these templates because they'll have a lot of the things that we need to use. So the most useful one I found is this fountain one. It's a very typical sprite-based particle emitter. So you click on that, you click OK. We're going to have to rename this. I always like to name things with abbreviations of their type in front. So we're going to go PEN, which stands for Particle Emitter Niagara. And we're going to call it Water Drops. The reason why this abbreviation is so long is because they're also the particle systems, and you want to be able to make sure that you can differentiate between the two in a list, and you can just type in PSN or PEN and be able to to pull up all your emitters or systems so you know what things are. So we're going to double click to open that. And that opened in a separate window for some reason, but we're going to drag it over. So here is the Niagara editor. First thing you'll probably notice that will catch your eye is the previewer window. So there's a previewer scene in here. You can change a bunch of things. You can look at FPS, things like that. I don't actually know where that's displaying right now, but you can change some of these things. You can change perspective. You can change what the lighting mode is or the view mode. So you can do optimization view modes like shader complexity, all kinds of super useful things. Usually you're just going to do it in lit just to be able to see what you're working on. And you can show the grid as well if you want to see where your origin is going to be. And also something I find super useful is to go up here to window and open up the preview scene settings, which is already open in this window over here. So it's just below the emitter tab, and you can come in here and you can change a bunch of things. And what I usually like to do is in this editor window, tick off show environment so I can see the particles and actually see what they look like, what they're doing. Because if you have small particles or particles that are fading out, it can be pretty difficult to see in that preview scene. So I usually just like to shut it off, and then when I actually preview things, I just drop them into the level editor over here and look at them there to see what they look like in the actual environment. So that's the basic functionality here. You can left click and rotate, right click and drag in and out, and then middle click to just kind of pan around. That's the viewport. And then down below the viewport, we have the timeline, which is new to Niagara. This is not something that was in Cascade. Basically, all the emitters that you're going to have in a particle system will be down here, and it will show what their durations are, which is the green part. It's looping into this yellow part, and you can sort of define, placement on the timeline and all that kind of stuff. And it's super easy to actually visualize in a simple way when your different emitters are coming in and when they're fading out, et cetera, et cetera. So that's super useful. And then also when you're using multiple emitters in a particle system, this is where you're going to be adding them. You can't do it in an emitter, but when you're in a particle system, you can add emitters down here or remove them. Also, there are curves here. So if you're editing curves over here, you can bring them down here if you want to visualize them against other curves, et cetera, et cetera. Also new to Niagara is this nice little parameters tab right here, which is super useful. So I don't have this. You have to make sure this is selected, and it'll populate all of these things. If you don't actually select an emitter down here on the timeline, then you won't be able to edit it. So make sure this is selected, and then go to this parameters tab, and you can see we have everything from high level engine parameters to if you're using a system, which we're not here, this is just an emitter, then they'll have system parameters in here. You'll have emitter level parameters, which basically pertain to the thing that's emitting the particles. And then you have particle level parameters, which pertain to the individual particles sort of over their lifetime. And there are all kinds of things like age, velocity, spawn rate, loop count, all kinds of things that are super useful in here. So each of these things has their own namespace, such as like particles dot what the parameter is, or emitter dot what the parameter is. There are other namespaces like user, which is things that you can create, which will then be something that you can use via blueprint to communicate with the particle system and inform and drive various things the particle system is doing. Then you also have other things that aren't displayed here, like there's a temp namespace, which is just something that's a temporary variable that will basically be around for one execution of the stack over here and then disappear, and then it'll be made again next time. It's just not stored in memory consistently. And there may be other namespaces that I'm just not familiar with, but those are the big ones. So then we're going to step over into the stack here, which is the bread and butter of Niagara. This is where all the work is done, and the lion's share of the work is done. And this is where you're going to be spending a lot of your time. So we're going to go and right click up here on the header and go collapse to headers, which is going to collapse this whole thing so that we can look at it high level and see what's in it. So the first thing to look at here is the emitter box, which is orange, and this contains everything that pertains to the emitter. So, in emitter properties, we have things like whether or not it's a CPU or GPU sim. We can set if it's local space. We can set the bounds. Very high level emitter things here. Then we step down. Those are all things that are happening at the spawn of the emitter. They only happen when the emitter is first created. Then we go down to emitter update. And these are things that happen over the life of the emitter. So the life cycle, such as loop count, whether you're delaying things, how long loops are going to be. And then spawn information is the other big important one. So how many particles are we spawning? Are we spawning over life? If you look up to the right here, you can see there's a little plus mark, and you can use this to add modules. So then you can go down to spawning, and you can also see we can spawn bursts of particles, or we can spawn per unit, which is if your emitter is moving, it spawns a certain amount of particles per every unit that it moves, and you can dictate all that. So these are the things that really drive the very, very base level functionality of the emitter. Super important. You're going to be tinkering with specifically the spawn stuff quite a bit. Some lifecycle stuff, especially when you're making more complex effects and you want to have a certain emitter delayed and then come in at a certain point to, like an explosion, throwing rocks out. You don't want the rocks to come out immediately. You want them after the explosion goes off. So there's that kind of stuff. The other things, since we're looking at this right side right now, is you can delete spawn rate, for instance, or anything that has a little trash can next to it. You can delete it. I'm going to undelete that, but you can do that. You can check this, and what checking this does is it basically turns off this module for the entirety of the emitter. So not only does it turn it off in the editor here, but it won't function in your game as well. So you can really easily debug things using this, but make sure that if it's something that you want in your emitter, that you turn it back on. So next we have particle spawn. So just like with emitter spawn, these are things that happen at the very beginning of a particle's life cycle. We have things like set variables in here, very basic. You set lifetimes of particles. If you change this to 0.5 and 0.6, for instance, they're not going to last as long. You can change it to a very long lifetime, and then you'll have a lot of variability. You can do a lot of things with that. One of the core functionalities that you're driving in your particle systems is going to be based on its lifetime, because also a lot of other effects are calculated over the particle's lifetime. So that's something that you're going to be tweaking quite a bit. Then below that, one of the standard things in this one is particles mass. So you can set the mass of particles, and this is kind of different to the methodology of Cascade, because they're trying to drive these particle systems largely as physics systems. So a lot of the templates that they have are based on calculating size by mass and calculating, velocities and such by mass. You don't have to do that. In fact, there are a lot of really neat workarounds that you can do to just kind of do things that were, essentially done in Cascade, where you're just assigning variables that really don't have meaning in terms of physics, but allow you to easily prototype out a visual effect. On the other side, if you want to drive a really realistic particle system for your game, like you're making a modern military shooter and you want, explosions to send off chunks realistically, you can do that in here now. And instead of just kind of having to fudge the numbers, you can actually figure out what the numbers should be and put those in. We're not going to be focusing too much on the realism side of things. I'm going to be focusing a little bit more on the hacky ways to fudge the numbers, because I'm just concerned about how something looks, and I'm making things that are a little bit more cartoony and, visually interesting in my eyes. But that's just something you can do and you can keep in mind. We also have particles sprite rotation set in here. So this is just determining the initial rotation of these particles, but of course they're circles, so it doesn't really matter. You can also add other things in here. So you click on this little drop down arrow up here and you go to add variable, and you can add any of these variables that already exists. So you can initialize them here. There's all kinds of stuff in here that's super useful. But what's even more useful is that you can go down and create new variable, and you can create any of these different types of variable types. And there's quite a lot you can do here. It's super powerful. So you can create a variable for whatever you want, and we'll probably be doing a little bit of that just to drive some more simple behaviors that aren't like physics based. So that's something that is very incredibly powerful. So if we just click, for instance, a float, you can see it just drops in a new float right here, and you can double click on it. You can change the name, just whatever speed, even though there's already a velocity in here. But so it starts off as a constant because I told it to be a float. You can actually come over here to this little drop down area, and you can do the same thing for any of these little variables or input boxes anywhere in the editor, and you can set how that is defined. So if you go to dynamic inputs, you can set any of these different things. One of the most common ones that you're going to be using is uniform ranged floats, as opposed to just being a constant. You set a minimum and a maximum, and Niagara is just going to pick a random value in between those and assign that to that per particle. Another interesting thing that you can do is you can also, for each of these, say you did a ranged float, you can then go down to this arrow, and then you can add another thing. So you could make your maximum another ranged float. I'm not sure why you'd want to do that, but you could drive your maximum by a curve, for instance. So float from curve, and you can do that over the particle's life. And you can see here that this curve is indexed by the particle's normalized age. You can also change that. You go to link inputs, and you can change it to any variable that is the correct type. So any float for this instance for a curve index here. I mean, this example of index is a little bit different because it typically tries to do time related things. But like, for instance, if you're going to set particle mass and link that to something else, you can usually, well, maybe not in here, but you can usually, if you set them down here, you can set them to anything that was up here, for instance. So if we go to color, or not color, we'll go to drag force, and then we'll go to link inputs, and then you can see it's not just the age anymore, but it's also got things like lifetime, mass, the speed variable that we created, all kinds of useful things. So there's a lot of functionality in this, defining how you set inputs, and then also nesting different types of definitions in there. Super useful. Another thing to look at in here, so we're gonna reset that and reset that. So this will just reset it back to a constant. Another super useful thing that you can use to define is expressions. So you can go down here and do make new expression. And basically what this does is it gives you a line to write in some HLSL code to define something. So you can pretty much do anything you want in here. I'm not super familiar with HLSL yet, but you can do a lot of simple math expressions. Like you could basically say like particles mass times particles lifetime, for instance, or you could do that for basically anything else, and then that will define that variable there. Now, like we noticed before, I don't think you can actually access these because they haven't been defined yet in here, but I think if you went to say here and we looked at link inputs, yeah, so everything that we defined above here is now available in here. So for instance, we could set this value, whatever this is actually doing, to be equal to lifetime times mass, or speed times sprite rotation, or whatever we want to do. So there's a lot of flexibility in there, and we'll do a small amount of that in here. Hopefully more in future videos we'll use that, because it's just super useful. It's a shortcut to not having to define your own module. Of course, you have now written some code in there, and it's not the most user-friendly thing. And so if you're handing off your particle system to somebody else, it's not going to be as easy for them to pick up and change things. So just keep that in mind. So we'll skip out of the variables here. We can look at some of the other things. There's calculate size by mass. There's add velocity. There's location here. So we're setting initial things here in spawn. These are not things that will change over the particle's life. So this is basically saying that these particles are going to have this initial velocity. These particles are going to spawn within this sphere radius. And so those are things that you can change pretty easily by going up here and just picking a different thing like velocities. There are a bunch of different kinds of velocities you can do. In location, there's a bunch of different locations you can do, and we're actually going to do some different ones for this once we get through going through the stack here. So as we're stepping down through the stack, we're going from first executed thing typically towards, what the final execution is going to be. So this is literally like stepping through an execution stack. So we're spawning particles, and then we're going to update the particles over their life. So there are a couple modules in here that are pretty typical that you're usually not going to mess with unless you're really doing something advanced, like particle update age, which is basically saying, the particle spawned every tick or frame, whatever the particle system's being updated at, we're going to update the age. We also have solve forces and velocity, which is another typical thing that unless you're doing like a stationary particle system, you're going to want to have this here. You're going to want to leave it here. And then you're probably not going to mess with it too much. It's just something that's there unless you're really doing some power user stuff. But we're not going to do that here. We're just going to leave that as is. And something to note with this is that anything that changes the velocity or the forces associated with the particle system has to be above this. So this can then use those inputs to calculate the forces and velocities. So if we, for instance, grab this gravity force, tongue twister, and drag it down below sources and velocity, forces and velocity, there it is. Okay, so then you open this, you look at it, it says it suddenly has unmet dependencies because this is not supposed to be after forces and velocity. So it's pretty smart. It'll have this little button that says fix issue, and that should push it back up. As you notice, like I clicked it and it moved it back up and it's not yelling at me anymore, but then you can look in the particle system and gravity is not working. So maybe if we turn it off and on again. Yeah, see, now it's working again. So just be aware of where you're locating your modules, because certain modules depend on other modules. And if you're updating a variable, for instance, and you're setting it here and then doing something else to it down here, the thing that's lower down is going to take precedence and be the thing that is written out at the end. So keep all that in mind. It's pretty important where you're locating things with respect to each other if they're working on the same variables. So then after particle update, or actually let's look through here. We can see that, there's a lot of similar stuff in here. Some of these things, some of these modules are going to be the same modules that existed in particle spawn. Not all of them. Some of them change because some things just don't make sense at all in particle spawn and do make sense in particle update. Because, you don't want something that changes a variable over life in particle spawn. That just doesn't make sense. So, same deal. You can go through here. There's a lot of stuff. You can search at the top for whatever you want. It's still in its beta stages, so some of the things that you might expect to see there that were in Cascade aren't necessarily in here, but you can work through those things on your own through defining variables, through making expressions, and then you can also, once you really get into Niagara, there are things called modules, which all of these are modules, but you can actually right click on this and open and focus it. And basically what it does is it takes you to the script for this thing. So this is a blueprint-like scripting system that defines what this module does, defines its inputs. We're not going to really get into the nitty-gritty of this, but I just wanted to show you that this exists, and this is a super powerful thing that makes Niagara, a very powerful tool set. And then once you learn to do these things, you'll be able to do crazy things with particle systems. You can make changes to existing modules, or what is probably more recommended is not that you change what's there, but you take this and you save it as something different. And as soon as you save this as its own thing that you made changes to, then it'll show back up in your module list when you go to add something. So really cool stuff. We're not going to do any of that in this video, but eventually we'll get around to that when I have a better handle on it. Now that we're done with particle update, we'll step into the event handler down here. So this is pretty cool, and we won't use this in this video, but we'll use this in the next video when we're really tightening up this particle system that we're going to make here. And so basically what you can do here is you can add an event, or you can add a handler for an event, and you can say if another particle emitter is broadcasting an event, I can add that in here and then tell this to either do something to every particle in my system or do something to particles that I'm going to spawn as a result of that event. And then you can go in to here and add modules such as receive, for instance, death event. And so if whatever you've registered here is sending a death event, then you can receive that death event and the payload that it sends, and it will then be, so this particular module will then write those payload attributes to this particle system, and then you can do things such as inherit location, inherit velocity. So if we go up here and look at particle update, we can also go to events and say generate death event. And so this is what is sending out this death event here. So we can actually even tell this particle system to receive its own death event. And so you can see it's doing some crazy stuff here, but basically when a particle dies, it's telling every single particle to go where that particle was. If we go here and just spawn particles, now when every particle dies, we're spawning more particles, which it gets a little bit crazy pretty quickly. We're not going to do that. So we're actually going to trash this receive death event so it stops doing that. But so if we go up to death event here, we can see that there are some variables that we're going to be sending every time a particle dies. So it's sending position, velocity, particle ID, it's sending a random float, it's sending particle age. And then what this is doing down here when we have that receive event is we're actually overwriting what the receiver particle has for location and velocity with what the dying particle had. So super useful. We're going to use that next video. It'll be great. For now, we're just going to close out of those two because we don't want them in this particle system yet. And we're going to go down to the very last section, which is the render section. And so the render section is where it takes all of the variables that we have been working on and it binds them to specific things like position, color, velocity. So you can see these things are bound very simply right now to what you would expect. Position is bound to particle position, color is particle color. But you can actually change these to a number of different things that fit into that same parameter type. So for instance, since a position is a vec3, you can do scale, velocity. Color, I think, is a vec4 since it's got alpha, so there's only that there. But you can create a vec4, so you can change a bunch of things in here. And this is super powerful. We're not going to change the bindings in this video, but just know that that is something you can do, and it is pretty cool that you can do it. So every single thing you can see where all of the variables are going. If you right click up at the if you go to this little eye icon and click show outputs, you can then actually go into each of these modules and see what the variables are that it's outputting. And so these are physics forces, and then this is taking physics forces to output things like velocity and position. So you can actually follow the entire chain of execution here to see what is actually happening in your particle system, and you can have control over every step of it. So that's pretty cool, pretty powerful, also very easy to break things. So just keep in mind when you change things like this, you can easily completely change the behavior of your particle system. So other things in the render that it's doing after it's taking all these things in, you can change sort order, you can do sub UVs in here. You can change sort and facing modes, which is pretty useful for sprites. Then you can also change the default material. So this is a sprite render. You're just rendering a little circle here with like a radial gradient fall off or something like that. That's making it kind of have opacity towards the edges. It's just facing the camera, and that's it. So the circles always face the camera. It's pretty simple. You can also come up here and add different things. So you can add, all these different types. You can add a light, you can add a mesh, you can add a ribbon or a sprite. So these are all different types of things that you can render based on the same particles. So if we do, if we do a ribbon, for instance, you'll see that it's actually taking the same variables and it's just rendering the ribbons based on those variables. So we don't have a material attached to this yet, but you can see all these gray lines that are just all over the place attaching different particles because ribbons are strung together and it's trying to string together all these different particle locations. But so it's really cool because you can do all the calculations once and then you can draw multiple things based on those calculations. So super useful, can be super efficient if you do it well. So that is the gist of Niagara itself. It's got a lot to it. There's a lot of different things you can do with it. We're just going to do a very simple particle system here just to kind of get our feet wet, just to show you what you can accomplish in here in a couple minutes. So we're going to start off. We're going to delete a bunch of stuff that we do not need. So I'm not going to calculate size by mass. I mean, you could do that for this kind of water drop particle system that I'm going to make here. If you wanted to do something super realistic, you could do that. All the masses included, all the, forces driven by the masses and stuff like that. But we're not going to do that right now. We're going to keep the mass just because all that stuff is expecting it right now. And I don't want to go that deep into it. But we're going to get rid of the size by mass and we're just going to size things ourselves. We're also going to, I closed that. We're also going to delete the velocity. We don't want to give it an initial velocity since we're having water accumulate on the surface and then drop down. We want to act on it over time with an acceleration. So we're going to get rid of this velocity. We're also going to get rid of the sphere location because we're not, it actually kind of looks like a neat little water faucet spout right there, but that's not what we want. So we're gonna get rid of the sphere location and we're gonna add a box location in a minute. But I'm gonna keep going down here and deleting things that we don't need. So we're actually, it might seem counterintuitive, but we're actually gonna delete the drag and gravity forces because we want to do it our own way. We are gonna have an acceleration due to gravity, but we don't want that acting immediately because we want the water to accumulate on the surface before dropping. So we're gonna get rid of that. Like I said, leave update age and solve forces and velocity because those are pretty crucial to the functions of this, but we're actually going to drag this color input up here because instead of changing color over life, we just want one static color that these particles are going to have because they're just little water drops. So we've done all that now. And let's just start off by changing the color. So we're going to reset this curve here to a constant. Like I said, we wanted a constant, and we're going to go 0, 1, and 0.97, and that will be our color. You can see this this material is additive, so it's just spawning all these water drops on top of each other, and they are getting super bright as it spawns a bunch of them. I mean, it's spawning like 100 every time, so that's a lot of particles just sitting on top of each other. So what we're going to do to fix that is go to this plus up here, go to location, and we're going to go to box location. So these aren't going to spawn in the same exact place. We're going to change the size to 200, 200, and 0 because we want it to be a surface. We don't want all the particles spawning at different heights. We want them spawning on a surface. So you can see they're just kind of spawning on a plane right now. So we're also going to change the lifetime here. So we're going to change this to 5, not 51, 5 and 10. So these are going to last a while. We're also going to want to knock the spawn rate down because this is a crazy amount. So we're just going to go like 5 right now, just so you can constantly see some things spawning here. So we're gonna continue changing these things. We're not gonna change the mass. We're fine with that. It's not that big of a deal. We're gonna get rid of this particle speed thing I made. That was just for the tutorial. Let's see. What do we want to do? Actually, you know what? I might just make the mass a constant and make that a constant 1. We're gonna reset this to a constant as well. I don't want these to have a random rotation. We'll go with 0. We'll go with 0 on that. So they all just kind of have the same rotation. It's not a big deal. We want to also add a sprite size because you can see these are all just, same size circles, and that's not super interesting. So if you click on this little arrow and you go to add variable, and then we go to sprite size, particle sprite size, and we're probably just going to make this a single vector, a single constant that we want to get, because these are sprites, and so they're only defined in X and Y, and if you make those different, then it's going to stretch the sprite. So we're just going to go vector 2D from float here by going to this arrow and typing in vector 2D, and it gives us that. So basically what that's saying is now it's going to drive both the X and the Y from this value that we put in here. So that's super useful, but what we're also going to do, and another reason why that was useful, is we can now just make a uniform ranged float as opposed to uniform ranged vector. So we can just input a couple numbers in here. It's super easy. We're going to go from 2 minimum to 4 maximum. So you can see now they're spawning with different sizes. They kind of look like little orbs of water right now. Maybe not totally realistic. We're going for more of a cartoony look here anyway, but they are a little perfectly shaped. But we'll kind of work on some of that later. So actually we want to change the spawn rate also to a range, because we don't want it to look like it's just constantly spawning the same amount of stuff. So we're going to go from 0 to 5 just to kind of give it a little bit of a random, more realistic nature. So you can see now they're just kind of popping in whenever, sometimes more pop-ins, sometimes less, but it kind of feels a little bit more realistic than just a constant rate. So now we've done all that. We also we're also going to want to just step into update down here now. I think we've pretty much knocked out most of the things that we want to add to the initial time here. So now we want to get to where we're updating the particles. So we want to update the sprite size over life, because as you can see, they just kind of pop in. That's super unrealistic. It doesn't look good. They just kind of pop into existence, and we don't want that. So we're going to go sprite size scale. So we want to scale the sprite size, and this is doing this every frame. So essentially what this is doing is, right now it's 1. It's just telling every frame the sprite to say to multiply its initial size by the scale factor. And since it's 1, it's just the same thing. In fact, it's not the initial size that it's doing. It's the actual size itself. So what Niagara does is it stores an initial size, and it stores the actual size that will be fed into the render. So I think if you look here, yeah, you can see there's, in particle attributes, there's sprite size, and then there's initial dot sprite size. And so basically what this is saying is this is the initialized value that it had when it spawned, and then this is what it currently is. So what the scale is doing is it's multiplying the current value by 1. So for instance, if we change this to 0.9, these should just kind of get smaller over life. Oh, actually, I might have it backwards there. It looks like this is just doing the... Yeah, it's the initial sprite size. Sorry about that. So it is doing the initial sprite size. If we wanted to, we could say it would just do the current sprite size by doing an expression in here, but we're not going to do that. What we actually want to do is act on that initial sprite size, because that's the easiest way to get a constant overtime effect that we like. So what we're going to do here is we're going to do a vector 2D from a curve this time. So essentially, once again, what we're doing is we are taking this curve here and we're using it over the particle's life to drive what the scale is going to be. And for some reason, yeah, there you can see it now. They're actually fading out slowly over time. What we're going to want to do is we're going to want to do this. So from 0 to 1, you can see it already starts at 0 to 1. And it's going to let you individually edit the X and the Y values. What we're going to want to do is we're going to want to select both because we want them both to be the same right now. And we're going to put this to 0, so they start off as nothing. And then we're going to go to time 1, which is the end of the particle's life. And we're going to put that to 2. So now you can see they start off super tiny and they go up quickly to 2 times their original size. So basically that's just giving us a little bit better behavior, saying that they're going to look a little bit more realistic. They're not just going to pop in. We're getting popping out at the end, and that's because the loop duration is only set to 5, and this thing is just going to 10 seconds and then ending. So these particles, some of them are not even getting to their full lifetime. So you're getting weird looking effect in here. But if we actually put this into the world, the particles would live out their full life and then just pop out of existence, which is also not perfectly what we want. So what we want to do is have these start to fall so that we don't see them pop out like that, because we want the water to accumulate and then we want it to drop off the surface. So what we're going to do is we're going to click plus, and instead of adding a gravity force, we're going to add an acceleration force because we want to customize this. So you see it's yelling because it, for some reason, added it below cell forces and velocity. So we're going to drag that up. And now you can see we have the Excel force module here. And so what we're going to want to do is we're going to, once again, drive this from a curve. So vector from curve. So you can see it's automatically going from 1 to 0 like curves typically do in here, but that's not what we want to do. So what we want to do is we want to start off, select all of these. I want to start them at 0 because we want the particle to accumulate on the surface. We want to come up here to this little box up here where there are these locks, and we want to lock X and Y because we don't want to change those. We're just having gravity act on this. So we just want to change the Z. So now those are locked. We can't touch them. In fact, we can turn them off where we can't see them because they're not important for us. So we're going to start at 0, and we're going to change this to negative 980 at time 1. Oh, that didn't take. So select it at time 1, negative 980. So basically, if we click this button up here, we can fit to it, and you can see that it starts off at 0, and then at time 0, it starts moving down to time 1 where it's at negative 980, and then it plateaus off because we've only given it those 2 values. But, that's kind of not ideal because obviously, gravity doesn't just like ramp up its force. It's a constant force over time, but also, the particles, you can look over here, are spawning and they're getting bigger as they're falling, which is not what we want. What we want is the particles to get bigger over time, and then like as they're getting to their biggest size, that's when they break that surface tension and start to fall. So we want to change some of these points a little bit so that it makes a little bit more sense. So what we're going to do here is we're going to add a point at about, we'll say 0.15, and we're going to make that 0. So basically the particles don't move to start off with. They take a couple, a second to 2 seconds, something like that, depending on the range, to form a little bit before they start falling. But still, we're not quite there. We want to add a few more points in here. So first of all, we don't want, just in case you didn't pick up on this, if you right click on the curve, you can add a key, and that's what I've been doing. So we're going to add this key right here. We're going to put it at 0.3 times 0.3, and we're going to do negative 980. So basically what's happening there is that there's a pretty, static acceleration due to gravity over most of the particle's life. The other thing we want to do is we want to add another point here, a little bit in the middle of these two. So we're going to do 0.26, and then we're going to call this about -5, we're going to say. And essentially what this is doing is it's giving us, we can zoom in here, before, you really have to zoom in to see that. But so this is negative, I did -0.5, that's why. -5 is what I meant to do. So now you can see, it starts off not moving, and then it starts to slide ever so much. And the reason why I'm doing that is because, if you've ever watched water drop, when it starts to ball up and get larger, just before it falls, it starts to kind of stretch a little bit because it's trying to break that surface, that adhesion or cohesion, I can't remember the exact term, but it's trying to break that tension that's keeping it attached to the surface. So that's what this is basically trying to show, is that they don't move, and then they just barely start to move, and then they drop. So that's just a little bit of detail in there that'll make the particle system look a little bit better. But you can see it doesn't move for the first third of the particle's life, essentially, and then or first quarter, and then it just drops, and then it'll just keep accelerating over time. So we have our acceleration now. We kind of want to change the sprite size scale to, gel with us a little bit better, because right now, essentially what it's doing is it's just accelerating over life, increasing over life. So the entire time the water drop is getting bigger, which doesn't really make sense because its water source is the surface that it's on, right? So we need it to only get bigger while it's on that surface. So we're going to add a little bit more to this curve. So first thing we want to add something to the X curve here. So right click, and we're going to say at a quarter of the particle's life, which is when it starts to move, we are going to put it at time 2. So essentially what that's saying is that the X curve is done at that point. It gets bigger and then it stops right when the particle starts to move. We're going to change the Y a little bit more because the Y is, there's a downward force acting on the water drop, and we want to kind of make that look a little bit more detailed and give it a little bit of stretch based on the pull that it's getting as it starts to move, and then based on when it just actually starts to free fall. So we're going to lock the X curve so we're not accidentally adding things to the X curve, because it's actually kind of tough to add things in here without selecting the right curve and not moving the wrong thing. So you just want to lock the ones you're not using. So we're going to start off, and we're going to say at time 0.2, so just before it's done accumulating, it's going to actually already be at its full length, right? So the full spherical length of this drop. So that's basically saying that gravity is pulling it down a little bit. So the water is accumulating more on the Y a little bit quicker because it's being pulled down. And then what we want to do is we want to actually give it even more stretch, because the force of gravity is pulling down on this thing. It's causing it to stretch. So at time 0.33, we want to go to 0.25. And so what that's saying is as it drops, it's going to have that constant stretch to it as gravity is pulling it. And then we're going to add another key here in the middle, which is going to be at 0.3. And we're going to put that at 4. And so basically what we're doing here is saying that, just like if you've ever watched water drop off of a surface, just before it starts to move, it gets really stretched out as it's trying to break that tension. So it stretches, and then it breaks that tension, and it snaps back to something a little bit more like its original dimensions, but it's still a little bit stretched because that force is pulling it down, and you kind of want to give it, this is cartoony, you want to give it a little bit of stretch to show the motion. So that's essentially what we're doing there, and I think that looks, pretty decent. it looks a little bit weird now that we're looking at ovals, but you're going to kind of embed this in the surface so that the top half of this is not really seen. So it looks a little bit more like a drop just coming down. So I think we're good at the size there. And now you can see this is kind of looking like, it's kind of looking like water forming on the surface, stretching and dropping. The only other thing we're really going to do to it in this video is we're gonna create a material just to show you what creating materials is like. This material is actually pretty decent for this. I mean, it's got a little bit of, translucency towards the edges that's sort of giving it a almost 3D effect. But I'd rather go for something a little flat shaded for this kind of cartoon effect. So we're just going to save this. We're going to go in here and we're going to create a material. And we're going to call that water drop. And then we're going to open that. And so we're going to come in here and we're going to click on this. And we are going to change this to masked and unlit. And the reasons why we're doing this are mainly, super performant. Like this is probably one of the most, like opaque is probably the only more performant settings that you could put in here for blend mode and shading model. Unlit takes a bunch of instructions out of this. If you're doing something super realistic, you probably want to be doing like a mesh particle with a translucent particle that has refractions and is affected by the light. But we're just going for something super simple here. So unlit works for us, masked works for us. So then that changes what we can do in here, what is available to us. But, this should work pretty well for us. So what we're going to start off with here is we're going to get a particle color node. So right click and then type into the search bar particle color. You get the particle color, you just plug that straight into emissive. So right now it's just white, it's not being fed anything. But when we put this material in our particle system, Niagara will actually drive what this color is. So we've got the color set. And I guess we could actually just save this and take a look at it so that we know what it's doing. So if we go to sprite rendering here, we can type in water drop and boom, right there. You can see it's got the color, but it's a bunch of rectangles right now. We don't want rectangles. We want, little drops, little spherical drops. So we're going to go back and we are going to add a sphere mask. And you could do this with the texture. I'm not really sure. I'm not really sure what's more performant. The texture is having to do a texture lookup and it's having to use, memory for that. This is going to be more instructions, but, probably less footprint on the memory space. I just wanted to do in this, this tutorial, just everything in the engine. So we're just doing the sphere mask, but you could do it theoretically with just a circle that you did in Photoshop or something super easy. Or you could do it as a specific shape you wanted to. If you wanted to upgrade this effect a little bit, you could do little water droplet shapes or a sprite sheet that you use for the sub UVs that you then can change the shape over time. But we're just going to stick with the sphere mask. We're going to plug that into opacity because we want it to define where the particle color is being drawn. And this sphere mask node has a couple inputs. It's got this A, B, radius, and hardness. A is basically like the coordinate space that you're working in. So it's basically saying where is this material relative to everything else. So we want to work in the texture coordinate space because we basically want to say where the sphere mask is going to be on this texture. And it makes sense if we look at it as a plane. But we need some more inputs here first. So the other thing is we're saying, all right, so where relative to this material or object do we want the sphere to draw? And so texture space is UV space, and it's from 0 to 1 on the X and the Y, or the R and G, I think, or U and V. Like it depends on what you're plugging in. But this is defined as U and V, and if you take, a color vector, you can do R and G. But so, 0 to 1 on the U and V. So we want something that's smack dab in the middle of that, right? So we're going to hold 1 and click to get a constant. And we're going to do 0.5. So basically what this is saying is put it directly in the center of our material. So you can't really see yet because we have not added a radius for it. So we're just going to say 0.5 for the radius because this is actually, that's the full texture space that we have, right? So you can see we have a circle now. And I also like to just kind of plug into the hardness here. You can see you get a slightly smaller circle. This is maybe not as performant for overdraw, but it makes sure that you don't have any hard edges. You could probably do, a harder number that's a little bit less, but we're just going to go with this for now because it works. It's basically the same numbers that they're using for the sphere mask in the default texture that we were using also. So this is a good starting point. It gets us pretty good effect, circle. So we'll go over and we'll look at this. And so now you see they're just, instead of having that little fall off of translucency before, it's just kind of a flat shaded like blue. Like this almost feels like something that would be in just like a cartoon, and that's the effect I'm going for here. You can notice that it's a little bit brighter, and that's because this is an emissive color. We can actually hold M and click to get a multiply node, and then we can multiply this by 0.5. So it's the same color, but it's dimmed essentially. Save that and let it apply, and then come back to here, and you can see it's a little bit less bright. I mean, unless you're like in full sunlight, you don't want your water to be super bright. And this is another thing to think about. Using unlit, these particles are not going to be lit. So this is heavily dependent on what your scene looks like, what you're going to want this color to be like. You could drive this as a parameter that you could then change depending on the scene. We're not going to do that here. We're just going super simple. But basically, as you can see, that works for our purposes. It looks all right. It's a super simple particle system, but it's there. It works. So now we want to look at it in the world. So we're going to go out here, and the first thing you'll notice is that you cannot drag and drop this into the level editor. And the reason for that is we just created an emitter. You can only place particle systems. So if you right click on this, go up to the top, you can go to create Niagara system, and then we're going to rename this to PSN water drops. And then we're going to drag this in, and immediately you're going to be thinking, oh no, we've done something wrong. There's nothing here, but you haven't done anything wrong. It's just kind of a quirk of the Niagara system. So we're going to open this, and you can see it's working here, and then suddenly it works here. I think it just needs to compile for the first time, but you can see that is functioning. So we can actually drag this up here and give this like a surface. So drag this up halfway in there, and you can just see now that it looks like water drops forming on the surface and then dropping. So if we take a look at this particle system real quick, you can notice it's got our emitter in it. It's down here. It's named what we named it. And then you look over here and you can edit all the things that were in the emitter here. So you notice it, it's pretty similar. It's almost identical. Main difference is that you have the system stuff up here. So there's system parameters that you can expose. There's system spawn and life update stuff. We're not going to touch any of that. What you will notice is that for each of these things, you can click this little yellow arrow to reset it to the default number. So that's the default for that module. It's not the default for the emitter. However, if you change anything in here, a green arrow will pop up, and you can click this and it resets it to what's saved in the emitter, right? So if we click that, the lifetime is back from 0 to 5. And you could do this for anything in here. Like we could just change that, and you see immediately it pops up with this green arrow, and we can change that. And likewise, you can actually go in. So let's just save this. We can go in and change this to red, for instance, and hit OK and hit apply and go in here. And now we have blood red drops, and it's just, they're linked. They should always, we're going to change that back. They should always stay linked. I've had issues where it wasn't updating, or it wouldn't revert back to what it should. And basically what you can do at that point is come down here to the timeline, right click on it and delete it, and then you can add the emitter again. Or, you know, also separate from that situation, you can add the same emitter twice if you wanted to. Now we have the same emitter going off twice. You can then go into each of these and individually change things in here. Like I can change the box location to 0 for all of these. And so instead of being distributed out, you've got this one little spot in the center that's doing all of the particles dropping. So you can make changes to template emitters within a system to then, you know, drive even further greater variability in there. We're not gonna keep both of these, though. We just want the one. And that's pretty much the basics of Niagara. So we have this system that we like, or, you know, it serves its purpose. I'm going to move this a little bit. It serves its purpose. It looks like water dropping. It's not perfect. You can notice that, you know, it just kind of goes to the floor and it doesn't do anything. It just keeps going and the particle lives out for its entire life. So, you know, we can add a little bit of dynamism to there to make it more interesting. And basically what I'm going to do in the next video I make is we're going to put a kill volume in here so that these particles hit the floor and then create another emitter that is a splash. So it adds a little bit more life to this particle system. It keeps the particles from going on forever. And then we can also add in some things that will allow it to be communicated with via blueprint, so we can set, for instance, where this particle system is and where the kill floor is. So that's going to be in the next video, but I think that should do it for this video. We've learned basically everything about the basics of Niagara. I may have missed a thing or two here, but I think overall we've got, you know, pretty solid foundation here for Niagara. We made a very simple particle system that has a little bit of detail in it and looks, you know, decent, cartoony little effects that you could just put in your game, and, you know, players aren't going to scrutinize it. It'll just be something that adds a little bit more atmosphere. So I hope you learned something in this video. I hope this was useful for you. I will continue making these, and, you know, if you have any questions, just put them in the comments. If you have any suggestions for things that I should cover, also put that in the comments. If you just found it useful, let me know. You know, if you're interested in more of this, then stick around and I will be putting out more videos soon. Thanks for watching, and I hope you have a great day.